In this lab, we were tasked with designing and producing an automatic VI characteristics tester that would allow us to quickly gather data on a JFET diode. In this video, I'll be walking you through the operation and setup of the automatic tester that we designed. The hardware that we used for this project included a MIDAC in addition to a summing and an inverting op-amp. We then used LabVIEW to create the necessary testing code and run it on a MIDAC. The hardware was set up as shown. By doing this, we were able to control the VDS and VGS over the transistor. On our front panel, we have the 4 display graphs that can be used to measure current activity and to display the final VI characteristics. Along with this, we have the 3 variable inputs that are used for setting up the delta ramp inside the program. These tell the MIDAC the range of VGS values that are being tested, along with the step to take between each of these tests. The Start, Stop and Save buttons are also accessible on the front panel, with a display on top to inform you what state the device is currently in. Our state machine has 4 states. First of these is the wait state. In this state, we are able to input commands using the buttons on the front panel to control the machine. The next state is the measure state. This is where a bulk of the work happens. After we press and measure, our ramp begins to ramp up its values. It will start at 0 and then move in 0.5 increments up to minus 2.5. These values will then be fed into the simulate signal block, which simulates a DC signal and then passes that off to the MIDAC to set our VGS. After this, it also is sent into the for loop. This for loop uses an increment block to count from 0 to 15. These numbers are then put into the data input on our DAC systems, where they are fed through into the summing amplifier and out onto our transistor. VDS and IDS are displayed on graphs and then stored in arrays for later use. This process repeats until all the tests are completed. The next state is the save state. This allows us to take the data arrays that we stored earlier, decompile them, and then recombine them. After this, we can save it as a .csv for later reference. The final state is our stop state, which stops the program from running further.